Thank you, sir. I'm sorry. I'll have two people. Yes. Let's talk about data science. You guys are all here to talk about data science. If you're smart, you get up your Saturday to do so, because data science, as you know, is a hot topic right now. It's a hot field. People are hiring like crazy. People are doing some amazing things with machine learning and predictive analytics, big data analysis, artificial intelligence. If you don't believe that data science is hot, try this experiment. Go to your LinkedIn profile and add the words data science somewhere in there and watch the recruiter spam go up exponentially. So yes, it's hot now, but it's funny because a lot of the algorithms and a lot of the tools around data science have been around for a really long time. It's really in the last few years that it's just exploded. And I would suggest that the #1 reason for this explosion in data science is the emergence of cloud computing. And cloud computing is a lot of things to a lot of people. So I'm going to start with my definition of cloud computing, because that's a term that's kind of been hijacked by the marketing people. Here's my definition of cloud computing. It's when you host some or all of your data or your applications, which we can have a third party hosting some or all of the data or your application in a highly scalable, highly reliable way. That's a very broad definition, but the high scalability and high reliability are important. Not every hosting provider has that in their offering. So I would recommend that when somebody says, we have our own cloud, you press them, what exactly do you mean by that? And the important part for data science, of course highly reliable is important, you don't want to lose data, but for data science is the high scalability part of it. This is probably the #1 reason why data science has been empowered by the cloud. Because what the cloud allows you to do is to scale out to meet increased demands. And data science typically, when you're running machine learning algorithms or artificial intelligence or deep learning tools like TensorFlow or CNTK, they typically take a lot of compute power. And traditionally, you might run these algorithms for days at a time. But a lot of the tools empower you to run algorithms in parallel. So tools like TensorFlow have been around for a while, and that lets you run these things in parallel. So something that might take 100 hours on one processor might take 1 hour on 100 processors. It's not quite linear like that because there's some overhead in managing that, but you can see that if you can spin up a bunch of instances of a service and run them in parallel, you make a lot more efficient use of your time and your resources. The big challenge of this is having that compute power available to you, because in the past what companies had to do is they had to buy those servers and they had to maintain those servers. That's a huge cost. If you want to buy 100 servers, then you're responsible for those servers. You have to put them in a room with temperature control and filtered air. You have to have security around that. When hardware fails, you have to replace network cards and hard drives. You have to make sure it's backed up and the power is some redundant power supplies. When the operating system needs to get patched, you have to patch it. When the software installer has to get patched, you have to patch that. All that is your responsibility. And these are all tasks that probably have nothing whatsoever to do with your core business. Your core business is analyzing the data and doing predictive analysis or artificial intelligence. But it still has to get done. But what the cloud allows you to do is to rent those resources as needed. Because often you're running these algorithms on lots of processes for a few hours, and then those machines just sit idle the rest of the time. It's kind of a waste. And this is the way that cloud computing is really empowering a lot of companies to reduce their hardware costs, increase their capacity, but particularly in something like data science, which tends to be really compute intensive for short periods of time, and then nothing for a while. All right, so what the cloud adds to this is things like automatic clustering. So clustering is a non-trivial thing. Clustering computers together, getting them to run in parallel, that can be handled for you by a cloud platform. This quick scaling, changing configuration, say I want to go from 1 instance to 4 instances to 100 instances. very quickly and without a lot of maintenance, then cloud platforms will allow for that flexibility you can. And of course, reliability, which typically for most cloud platforms involves redundancy and monitoring. So if some piece of hardware fails, then it automatically will fail over to some copy of that data or copy of the application. All right, I want to talk about some of the tools that are available in cloud computing that will empower data science. My name is David, and I work for Microsoft. So the examples I'm going to give happen to be Microsoft Azure tools, but there's the cloud computing market's pretty competitive. When we see what our competitors are using, we tend to adapt things that are successful that people want, and the same thing is true on basis of computing. So you can find something similar to these, just about all of these, or just about any other cloud platform, whether it's Microsoft Azure, Amazon Web Services, Google, IBM, all those things have some version of almost everything I'm going to talk about here. First one I want to talk about is HT Insight Spark. HT Insight is just our branding, but Spark is part of the Hadoop big data set of tools, which is an open source set of tools that's really popular in the big data world. And Spark is just a general purpose compute engine. You can deploy anything to it. You can store data, you can run machine learning algorithms, you can publish Jupyter notebooks to it. What the cloud adds for this is a very simple way to scale out your solution. If you want to go from a node of 4 clusters to a node of 20 clusters, you can do so with just going to this dashboard and changing a value and clicking save, or writing a few lines of script to automate that process. So that non-trivial thing of managing your clusters, you don't have to destroy your cluster and recreate it. That's taken care of for you through the cloud using HT Insight Spark. You can run this locally, but part of that I call the plumbing stuff, the stuff that isn't directly pertinent to your business. You're respecting the way, you're letting somebody else take care of that. There are also some monitoring tools that will help that as well. Now Spark does allow, you don't have to create your own solutions and deploy them to it. So just recently, Microsoft introduced something called Azure Databricks, which is built on top of Spark, and that has some simple ways to do some of the more popular things. Like, for example, if you wanted to deploy Jupyter notebooks, then there's an interface that just says new Jupyter notebook or open existing Jupyter notebook, and it'll deploy and it's tied to a Spark cluster, create a database, or manage your clusters. There's a nice simple interface for doing this. You'll see this in a lot of cloud computing. They'll take tools that already exist, open source tools, they'll deploy to the cloud and let people use them, and then they'll add tools on top of that to make it easier. For example, you want to aggregate more than one tool together. Next thing I want to talk about is a data science virtual machine. Most cloud platforms are built on top of virtual machines, and virtualization allows for a lot of flexibility. Distributions can spin up multiple instances of identical machines and run them in parallel. But if you create your own virtual machine, typically you have to install your own operating system, install the software on it, and the data science virtual machine comes pre-configured with all of these tools. This list I took from about 2 months ago. It's probably more now. So popular tools that are popular with data scientists like TensorFlow, CNTK, Anaconda, Jupyter Notebooks. There are several databases, both relational, non-relational. There's IDEs. All these things that you might want to use in your data science solution, they're pre-installed. So it's unlikely you can use all of them, but it's kind of nice to be able to spin up a machine and get it running right away without having to configure, without having to run a bunch of install scripts to do this. And once you have it, it's your machine. You can SSH into it. There's actually Windows versions and Linux versions, so you can either use on desktop or SSH or some of these graphical tools that are popular on Windows platform. We like it with the GUI, so some tools allow you to get to the graphical interface. All right, for machine learning, typically if you're writing machine learning to do predictive analysis, you're writing a lot of code. Writing that code in Python or in R. But there's a tool called ML Studio that allows you to graphically drag and drop shapes to build this solution. This may seem like unnecessary for those of you who are experienced with building machine learning solutions, but it can be a really nice accelerator because there are some things that are just common to all machine learning problems. For example, you'll have to get data from one or more data sources. And it's nice to drag a shape onto a design surface and set some properties to say things like, oh, this is the data source of the data, point to some URL, it's a comma delimited file, it has these authentication credentials and so on. And then you're done. That's code that you don't have to write. Splitting data into X%, 80% testing data or training data, 20% testing data, that's a very common thing. Well, the shape you do that, you set 80% and you're done. That's code you don't have to write. And then there are shapes that actually allow you to write custom code in R or Python. And that's where you'll spend your time either designing the things that are specific to your application, writing code that's specific to, that's not common among all or most machine learning problems, or cleaning up your data, which is 90% of data science is cleaning up the crappy data. And then the next evolution of that is a machine learning workbench, which is a tool that allows you to work locally and then deploy to the cloud. Sometimes it's more cost effective than building everything in the cloud. Now, it doesn't come with the scalability as you're developing it, so you probably want to test things on a small data set, but once you're done, then you can deploy them out to either a virtual machine or a Spark cluster or a Kubernetes container cluster. There are options for that. Azure notebooks are just Jupyter notebooks in the cloud. And Jupyter notebooks are just, they're kind of like Google Docs for data. They're a combination of formatted text and executable code. And so they're really nice for running code and showing the results of that code along with some annotations to describe that code. So for reporting, they're really nice. You can provide these things here and run the code and get real-time results with some description of what those results mean in the formatted text. And that code can be Python or R or SQL or Scala. All these things are supported. I think studying data science right across Jupyter Notebooks really quickly. Azure Notebooks is just a quick, free way of deploying Jupyter Notebooks in the cloud. You can go to notebooks.azure.com, spin up one for free. And finally, cognitive services. I really like cognitive services because they give you a way to take advantage of machine learning without actually doing any machine learning. Machine learning has already been done. These are web services that you can call that will do things like analyze images, analyze text, analyze speech, recognize a speaker or text-to-speech or speech-to-text, do sentiment analysis on text. So if you wanted to analyze, let's say, all of the comments in a blog post, find out whether the generally positive comments, negative comments, get scores on that. You can look at the pictures, and it'll tell you, give you a description of what's in the picture. It'll find all the faces in the picture and tell you information about those, like how old each person is, and what their gender is, and whether they're happy or sad or angry. It'll give outlines of eyes, nose, and mouth, and oh gosh, what else? Tilt of the head, facial hair, all sorts of information about the image. It'll even recognize celebrities, like this celebrity right here, who is
Satya.
Satya, yes, that's my boss's. So recognize celebrities, and then there's ways, just a simple web service call recognizes Satya because he's already famous, but it probably wouldn't recognize me because I'm not famous. Yes. But there's other web services where I can train. I can just provide some images and say, these are pictures of David, and here's some more pictures. These are pictures of Oksana, and I can provide information or pictures of people on my team and train it with a simple web services call, and then it would recognize a group of people that I've identified. And that might be nice for building role authentication applications. So you want to do facial recognition before somebody comes into a room, have a webcam set up, and take a picture of them, identify that. Make sure there's somebody that's in your group before you allow them in. Let's see. All right, so I talked about a lot of tools, and I talked about it really fast because I don't spend a lot of time here. These are the tools that I talked about. So you're probably asking yourself, well, that's a lot of tools. Which one should I use? And if there are any consultants in the room, then you know the answer to this. The answer is, the consultant answer is always,
it depends.
It depends, yes. 15 points. And so the reason there's a lot of tools is because there's a lot of uses for these tools. There's not one solution that fits every problem. But here's some factors. Here's some factors you can look at that'll help you to determine which tool is right for you. One is, do you already have an existing solution? Maybe you've built something on premises. Maybe you've built a tool using TensorFlow, and you just want to take advantage of the scalability of the cloud because you want to scale it out to 100 machines, but you don't want to buy or maintain 100 machines. Then data science virtual machines might be the answer. Or maybe you have an existing set of skills that you and your team have. They're really good at Jupyter notebooks, and you want to keep on using Jupyter notebooks. You don't want to spend a lot of money. Let's use Azure notebooks. So we're deploying Jupyter notebooks to Databricks. Using those tools might be the answer to that. Of course, cost is always a factor. And some of these things are free. The Azure notebooks are free. Some of them can be really expensive. You spin up a Spark cluster and add 10 nodes to it and make them all high-powered machines. You can run up a build very, very quickly. Computing in the cloud can be expensive. And I would recommend that as you're deploying a solution, you take care to shut them down when they're not in use. So you're only paying for them while you're using them. But you want to take that into consideration. Look at the cost of these things. Everything is published. It's generally quoted by the hour. I'm not sure what other cloud platforms do, but what Azure does, it rounds up to the nearest thing. So if you only use 10 minutes of compute power, you pay for 10 minutes. Something how much scalability do you need? That's a factor. The Jupyter notebooks, or sorry, the Azure notebooks really don't have a configuration to say I want to scale this out massively. But if you want to use Jupyter notebooks in a highly scalable environment, you could deploy them to Databricks, for example, and that would add to the scalability. So which tool? Some tools give the flexibility to manage the size of the machines they're on and the number of instances of machines. Some are better than others. And then the common trade-off, or the really common trade-off in computer science is how much control do I want to have versus how much work do I want to do. So if my philosophy on this is that if there is a solution to my problem that's pre-built and works, I will use that. 99% of the time, I will just use that. And so, for example, cognitive services. With a few lines of code, you can call a web service and get back some data. And all I want to do is just image recognition, motion recognition, or sentiment analysis. That's a no-brainer. I'll just call that. I could of course build my own solution, build my own models, train them, test them, and deploy them. And I can do that in tools like ML Studio. But why bother? It's been done for me. Now it may be that it doesn't recognize the things that I want it to. Maybe I've got a dot matrix printer, and there's a service for doing optical character recognition, but it doesn't work on this dot matrix printer that's printed on the side of a milk carton. And I want to recognize that. Then I'll go and I'll start building my own, maybe using deep learning tools, using machine learning tools, because I need that control. So how much control you need versus how simple your solution is. This is a trade-off that you run into over and over in all aspects of computer science. It's certainly true. And then, of course, you're not limited to one. You can store data on a data science virtual machine, analyze it with Azure notebooks. Those notebooks can call out to ML Studio solutions. So you use what you need. That's it. My name is David. I am actually, I just changed my title. I'm now a senior software engineer. So I don't, but this is my contact information. And I thank you so much for your time, and I will take questions. Thanks. Question right here.
Yeah, I've never used Visual before, but as a potential user, I guess the first question pops up is, what small stance Visual compared to other cloud services like AWS?
You're asking how does Azure compare to other cloud services?
Yeah.
Okay. So that's a big question, and I will just say something I said earlier, which is the cloud computing market. There's only in this sort of massively scalable cloud computing market where people have global data centers all over the world. There's only a few players in that: Amazon, Google, IBM, Microsoft, probably a couple of others, and they don't exist in a vacuum. So what you see happening a lot is that if one company changes the prices, the other one tends to change the prices quickly afterwards. If one company releases a service and it becomes very popular, then other companies will notice that and they'll start to they'll build something similar. And so Azure functions are a direct result of AWS and Lambdas were really popular. We didn't have anything similar, so we created Azure functions. So as time goes on, they tend to converge. But the answer, I don't have a specific answer for you, but it really depends on what exact solution you're trying to build. Are there any other questions? Great, I can have breakfast. Thanks a lot. Oh, there's a question in the back?
I think someone had a question.
There is a. Oh, yeah.
Yeah, question. You mentioned TensorFlow,
Yes.
but in the list it was missing.
Say again?
In your slide,
In this.
I didn't see TensorFlow.
It's not in here.
Yeah.
It's at the top, very first one.
Oh yeah, I'm sorry.
Yeah, and this list is not exhaustive. It's actually I had a truncated. It's kind of a slide that it's getting you over to. Yeah.
Are you familiar with AWS recognition?
I am not.
Does Azure technology provide image recognition set of libraries where there's a whole bunch of images pre-identified? You want to train your model to recognize images specifically in a certain font.
Oh yeah. So the question was, does Azure provide a service that will allow you to train a model based on images that you submit? The answer is yes. There is the custom vision API does exactly that, and it's similar to the one I described about recognizing people, but instead you would add images, you provide tags to that images. One example would be, let's say you have your factory builds custom parts. And the internet hasn't seen these parts yet because they're your parts. They're not out on the web, they're not indexed, but you can do that. You can say, here's a bunch of pictures of part number 1, 2, 3, and a bunch of pictures of part number 4, 5, 6, and then train it. And each one of those is just a web service call. A web service call to add the image, a web service call to add a tag to it, and a web service call to train the images. And then once you're done, a web service call to say, here's a new image you haven't seen, which part number is it? That's in custom vision. I will show it to you quickly. It's in one of the cognitive services. And I think the shortcut to it, well, not online. If you go to Microsoft.com/cognitive, it lists all of the cognitive services. And I think this one is custom vision. .ai. I believe that's it. But I may be misspelling it.
Okay, but it's somewhere cognitive services.
I spell it, it doesn't matter. I'm not online anyway, so it's not going to it's not going to go there. But go to Microsoft.com/cognitive and look under the section that's vision, provision, and you'll see that. And I'll try to get back online to talk.
Does that take advantage of retraining?
Yes, retraining. So the whole idea behind this is this one will do some machine learning. This is where you are doing the machine learning, but it's simplified because all you have to do is just make one web service call and say.
No, I meant reusing ImageNet model.
Yep.
And just adapt it for your data.
That's exactly what it is. Yeah, under the hood, I don't have any information about the technology that's being used, what tools are being used to do that training. But as far as you're concerned, you're just calling web service to say add images and tag those images, and then train that model based on all the images and tags that. And when you're done, you have a web service you can say, just send it a picture, return some JSON that says which tag matches this image.
Is object detection part of it? Or is it not?
Object detection part. What do you mean by object detection?
Putting bounding boxes.
Oh, I'd have to look at that. I'm not sure. I know that the face recognition does a bounding box around the face. I'm not sure if if it recognizes a picture of product 1, 2, 3, will tell you where you're going to be. I would test that. Okay, now with 1 minute left. Thank you very much.
Thank you so much for sharing with us about how cloud computing empowers the data scientist. So as